Continue on with the 5-axis. We need to go back to design mode, and we're going to bring in our fixture. We're going to bring our UMC 750 vise setup into this program. Okay, and it's going to come in at some odd angle. Drag it out of the way, and then spin it so it's in the orientation we want. So that's roughly the orientation we want. And move it down below our part. Now we can go ahead and say OK. One thing we are going to do is have to unground the part we just brought in. And we're going to do a joint between the point here that I have on the fixture and the bottom center of our stock. Okay, and that can be a rigid joint, that's fine. But that should center it in the one axis. And then the jaws on this model are free floating, so you can either choose to make another joint or just move in position. I tend to not use the collision detection much, so I just move it in there so for visualization purposes. Okay, and so that's how our part's going to mount in the machine. Make sure you've saved at this point, and then we're going to close the navigation window here. So this will allow us to toggle the fixture on and off depending on whether we want to see it. Okay, so our first operation is really a 2-axis operation. What we have here in the model is our stock. So let's go to our manufacturer mode. And we're going to minimize operation 1. And we're going to create a new setup. Our model, we're going to expand the models. And we're going to select the part as our model. Our orientation for this is going to be Z-axis is the top with the X-axis line going horizontal here. And it looks like we need to select our box point again. Alright, so that's where our origin should be. That way we can touch probe the edges and the top to find center of our material. Now if we go to the stock tab, it's not going to be from previous, we're going to do from solid, and we're going to select the model of the stock. Okay, we'll go back to setup, and this is where our origin should be. We're going to hit post process. This is going to be 3012. It's the second setup for part bending in 301. And this is going to be op2 UMC 750. And we're going to go ahead and use offset number 1 as well. Hit OK. And our origin should pop up where it needs to be. We're going to call this op2 in the setup section so we can make sure that's consistent. Yeah, our first operation, we're going to work from the more or less the top down. Okay, our first operation is going to face mill this off. We're going to go to face mill. We're going to select our tool from the UMC library of tool 1, which is our 3-inch face mill. And this is going to be very similar. We have our presets on our feeds and speeds, so you should have about 2,170 RPM, 50 inches a minute, and 25 inches for feed rate in ramp and plunge. Multi-axis, we're going to leave that at default. Orientation, geometry, we're going to accept what it accepts for default there. Then we're going to go into heights. We're going to go from stock top. We're going to retract at stock top, we're going to start cutting at stock top, and we're going to cut down to the model bottom. That should be good. We're going to go to passes, And our pass direction at 0 degrees is fine. Our pass extension, let's go 1.7. Oops. 1.7, not 440, 1.7. And we're going to do a step over of 3 inches because we want to go right down the center line and just have one pass. Okay, and we're not going to do any multiple deaths. We should be able to do this all in one pass. In our linking, we're going to keep the tool down. We are going to do a 0 vertical lead in. And we'll leave that as it is. Hit OK. We got our move. That should only be skimming 10,000ths off the face. Now we're going to go on to a contour. We're going to contour the perimeter of the model. So at this point we need to hide the stock so that we can select our part model. And we're going to do a 2D contour. And we're going to select the 1/4 inch end mill. Okay, our preset should be there. The reason we're picking the 1/4 inch end mill, this fillet here is a 300,000ths diameter, and so we have to go in with a cutter that's smaller than 300,000ths. Okay, we got 5,000 RPM, 27 inches a minute, 13 on our plunges. We're still doing 3-axis machining. We're going to select the bottom contour of edge of the part. That should be the silhouette. On heights, we're no longer going to go from stock top, we're going to go from model top for both the retract and top height. And we're going to go a little bit past the selected contours. The selected contour was the top of this chamfer. So we want to go a little bit farther, and we're going to go to the lowest of selected, and it's going to be the model bottom. Now this cut is going to come really close to our vice jaws. We need to be watching this when we actually run it. Typically I go a little bit deeper, but I'm going to be conservative on this. If we end up with some flash, we got to cut off on the opposite side, and so be it. Alright. We're going to go to passes. Okay, first 2 boxes are default. We're going to go to wear so we can use cutter comp. Now on roughing passes, our maximum step over is going to be 0.2. We're going to do 1. We're going to do multiple depths. We're going to go, I don't think we're taking a great deal off, so we're going to go 1 diameter in depth. We're going to do 1 finishing step down, and it's going to take off 0.008. We're going to finish at each depth. I don't think we have enough flute length to do the full length of this part. And we're going to use even step downs. I'm going to minimize the roughing cuts for the moment. And we look like we're good there. Go to the next tab. We're not going to leave any stock to leave. We could turn on smoothing. Let's go ahead and do that. It puts in the tolerance. It's really going to only affect the internal radius there. And we're going to leave feed optimization alone at default. Now we're going to go on to the linking tab, and we want to keep our tool down so it doesn't keep picking up. Horizontal lead-in radius is fine. Sweep angle at 90 is fine. Linear lead-in distance should be okay. Let's go ahead and put that in as 0.13, which is a little more than half the diameter. We're not going to have a vertical lead-in radius. And we do want to select our preferred lead-in position. And we're going to put it right here on this corner here. And we'll see how that goes. But that way we can see it where it starts. And hit OK. Now we should be getting a rough cut and a finish cut on each pass. We've got a lead-in radius here. Hopefully that helps us with any dwells we might have occur. And we should see a fillet on the finish cut here. That means we're cutting the full radius. Okay, most of the material removal is actually going to be over on this right hand side, where it's going to take, looks like pretty close to a full radius cut, which should be fine. Alright, moving on. Next feature from this angle would be the pocket in the center. Okay, we're going to come over with a larger cutter to do that, remove the material. So we're going to do a 2D pocket. I'm not sure why that popped up off the screen, but here we go. We're going to select our 1/2 inch end mill from our library. UMC 750. We're using a 1/2 inch 3-flute end mill. And spindle speed 5,000 RPM. We should have 54 inches a minute and 27 inches for ramp and plunge. If you don't, change those. Got a multi-axis, nothing to select there. We're going to go to geometry, and we're going to select the floor of the pocket. We're going to go to heights. We're going from model top on both top height and retract height, and we're going to go to selected contours. Okay, on passes, we're going to go left is fine. Our maximum step over is going to be 80% of the diameter of the cutter. So if we go back to our handy dandy calculator, it's 0.5 times 0.8 gives us 0.4. So I'm going to put you 400 thousandths maximum step over. We could use more spiral machining. I'm going to leave that alone. Smoothing deviation, we're going to leave alone. We'll go ahead and do multiple depths. We're going to do one finishing step down at 8,000. Our maximum rough step down will be 0.5, so that's one diameter. We're going to do even step downs. We will do a finishing step. Compensation is going to be wear. Finishing, we're going to do one finishing pass. I'm not sure why the smoothing deviation is defaulting to 0. Let's put it at 4/10 just to make sure we have something in there. And our finishing step over is going to be 10 thousandths. We are not leaving stock to leave. And on the smoothing tolerance, it should be 4/10. We are going to finish only at final depth. And we're going to go to the linking tab. We want to make sure the tool is held down, leave the lead-in radius alone. We're changing our sweep angle to 0. And our lead-in distance needs, since we're going to 0 on that, we're leading in off the workpiece. We need to set our lead-in distance as at least half the diameter of the cutter. So we got 260 thousandths. We're going to have 0 on our lead-in radius. And our ramp type is going to be outside the stock, so we're going to ramp outside of the stock so that we're not ramming into the material with our plunge. And we're going to go hit OK. And here we go. We've got our initial lead-in is in the center. It's going to come back, forth, and jog. These green sections should be at our regular feed rate. And then it's going to come back and do our finish passes along the edges. And if we zoom in, we should have not only a finished pass in X, but also in our height. Okay. Now, we're done with that. The only other item we have to do from this angle is the chamfers that run around the tops of these two islands. So we're going to go 2D chamfer, and we're going to select our chamfer mill from our UMC library, which are 3/8 chamfer. And let's go ahead and take the default settings, and we're going to chase around. We're going to pick tool orientation, leave it at default, or geometry, is going to be the top two tops of these islands, if you want to call them. And then we're going to go to our heights, and we're going to start at model top on both. And then we're going to go to our selected geometry on height. On passes, we're going to use wear compensation. And because the chamfers are modeled, we have to set our chamfer clearance of 0. And we can leave the chamfer tip offset there. And we leave the chamfer width off. I'm going to pick the smoothing deviation. It'll just allow it to go around this corner and wrap a little bit better. Then we go to the linking tab. We want and we're going to set 0 in our horizontal lead-in radius. We're going to set our sweep angle as 0. We're going to have 0.0375 as our linear lead-in distance. We're going to check that we're going to come perpendicular to our part. Lead-in vertical radius of 0. And lead out, exit, and same as lead-in. We'll select OK. Got our two profiles that go around the outside. Yeah, that's it for our 2-axis chamfer moves. And now we're going to do some rotations. So we're going to do the tapped holes in the end. That should be familiar. They're 1032s. And let's go to drilling. We're going to select drilling. And we're going to select our tool is going to be the same tool we've actually just been using. It's a milling tool. And we're going to do our center or spot drilling with it. So from the mill library, we're going to grab our 3/8 chamfer. We're going to select that. And we're going to leave it at its default feeds and speeds. We're going to go to our multi-axis, and we need to select the tool orientation. So we're going to select our Z-axis and then our X-axis orientation. And it looks like we need to flip it. And so that X is pointing to the right. We're going to go to geometry, and we're going to select our 3 holes. And again, we're just using the spot drill. So we're going to go to the heights tab, and our clearance retract height is going to be the model top. And we're going to go from the hole top, but our bottom height is also going to be from the hole top. And then we're going to put a negative number in here. So if you recall on the other one, we wanted a 10 thousandths chamfer here. If we take the nominal major diameter of a 1032 screw, it's 0.19, and we want to add a 10 thousandths chamfer on each side. So that's going to be 0.02 for 20 thousandths. Adds to the diameter. So we want a 210 thousandths diameter chamfer. And because it's a 90-degree chamfer, if we divide that by 2, we get 105 thousandths. Which will, in the negative direction, should give us the chamfer depth we want. Okay, we're going to go over to the drilling cycle, and we're going to do a deep drilling cycle. Now, if we had a spot drill, we would just hit this all in one shot, but chamfer mills are not really designed to do this. And we're going to do a 60 thousandths peck, and then we're going to do a 1 second dwell at the bottom of the hole. We'll hit OK. So we shouldn't have a tool change between this. It's going to rotate, so we're going to want to make sure we're watching it when we're actually running it, because we're going to go straight from making chamfers on the top and then get a B rotation could come quite rapidly.